So welcome to this webinar hosted by Akamai. Subject today is HTTP2 Uncovered, and we're going to introduce some top tips for a successful implementation. We're joined today by Richard Still from the Financial Times, and he's been working with Akamai on implementing HTTP2 on their new website, and is going to share with us some of the challenges that they faced in a real-world example as we go through. So before we get started with the main content of today, it's probably worth just going through a few housekeeping tips for you. All the widgets in the console are resizable and movable. You can drag them around your screen and arrange it as you please. If you want to make them bigger, then just drag at the bottom right-hand corner. If you turn off pop-up blockers, they may interrupt with some of the features, so for the best experience, make sure they're turned off. As a note, we're not going to be emailing out the slides from today. However, they are available to download from the portal. If you click on the green icon, you will be able to download all of today's slides. We're going to take questions at the end. So if you do have questions as we go through, feel free to open up the question and answer tab in the red button, put your question in there, and then we'll go through as many as we can at the end of this. If we fail to get through all of the questions, then we will reply to them all via email after the event. There's also a helpful tools section which can provide some other technical support with the green question mark icon. Some other useful features as well. Hopefully you can hear us okay, but if you do need to adjust the volume, then there's an adjustment in that bottom right hand toolbar as well. The ability to email us and tweet us or tweet about the event, and then there's some also information about today's speakers. Also within your console, on the left-hand side, there's also a menu of other resources that we've added in there. These are not resources that we're going to be covering today, but are useful HTTP2 resources that can help answer any other questions you may have. Before I hand over to Rick to give his implementation story that he's gone through with the Financial Times website, I want to introduce myself. I'm Michael Gooding, and I work at Akamai as a performance evangelist. And I just want to take a bit of time talking you through a little bit of the history of H2 and how it's come about, and some of the key features that we can expect to see moving forward. If we go back to 1999 and look at what a typical website looked like, the example we've got here is the Mail Online. And you can see that it's a lot of text, not a lot of images. There wouldn't have been many objects around here, and ultimately this web page would have been small. In 1999, we would have been using HTTP 1.1 that had been finalized as a standard 2 years previously. If we move forward 5 years, we can see that the website kind of starts to change a little bit. We see the introduction of a menu down the left-hand side, and no doubt this menu would have been powered by some JavaScript files, as well as lots of other functions, and we start to see more images on the page. In 2009, we see even more images. That menu has now spanned across the top of the page, and we start to see more and more rich content on our websites. Fast forward to last year, and even bigger images now, probably more functions, more connections, more resources on the page. So what we can see from this timeline is that the content we're delivering, the experience we're giving the end user has really changed over time. What hasn't changed over time, though, is the protocol in which we deliver this on. Up until last year, the only option available was still HTTP 1.1. So, although websites have changed, historically the protocol in which we deliver them hasn't. What we have managed to do, though, over that 15 years with 1.1 is we've managed to make the most of the tools we have available. We really did, we've completely changed in what we're delivering, and yet we still managed to do it in relatively performant terms. Along the way, we've managed to write books that provide best practice advice. So if we go start on the left-hand side, we had Steve Sauder's original high-performance websites, and then he built a second one, and then followed up by Ilya. There have been many other publications since. We've also managed to build ourselves tools that offer advice. So Why Slow Fireblog will tell you why your website, based on the rules from the books that we've written and that Steve Sauder's originally formulated, we've now got tools that can advise what rules we're meeting and where we can make improvements to improve the performance of our websites. We've also now developed tools that can help automate some of this. So when we go away and we build our code, we can then go and apply some of these best practice rules after that code has been written, and before we deploy our websites. So although we've now got all these great tools and books and advice around how to improve performance over HTTP 1.1, essentially all of these bits of advice are just workarounds for the lack of protocol support for today's modern requirements. As we've seen, websites have got bigger and more rich in content. So about in 2007, the decision was made that actually, rather than kind of keep working towards these or using these workarounds, we should actually try and fix the problem rather than papering over the cracks. So as I mentioned, around 2007, the decision was made, and that was made by the forming of the IESG group, the Internet Engineering Steering Group, and there was a decision made that we should address some of the fundamental issues or the holes within HTTP 1.1 in order to build a better protocol that could provide better performance moving forward. Some key dates along the way: in mid-2009, Google submitted an experiment called Speedy, which took some of the main objectives that were set out for the new protocol and actually put it into practice within Chrome. If we fast forward on to March 2012, a significant date when Firefox actually introduced support for Speedy within their browser in Firefox 11, and by Firefox 13 it was turned on by default. This was significant because this was the first time that a competing browser had adopted the protocol that was put forward by Google. Shortly after that, there was a call for proposals put out for HTTP2. This resulted in 3 proposals being put forward, but Speedy was the one that was chosen as the basis for H2. Following on from that, in November, the first draft was submitted, and this was, like I say, based on Speedy. If we then fast forward on to August 2014, the final H2 draft, which was number 17, was published. And then finally, this year in February, the standard was approved by the IESG. Although HTTP2 was finally ratified in February of this year, there have been many working implementations of it over the last year or so. There's a working demo. If you go to http2.akamai.com/demo, there's a side-by-side set of connections, and this picture will load little panels and show you the difference between them when you're loading. And you can see by the example on the right, the HTTP2 version, that even though there's a high latency, then the page loads or the image loads in a lot quicker. If we go and have a little look at the waterfall charts, then essentially in the HTTP 1.1 world, you're seeing lots of images all concatenated in the waterfall kind of at an angle. And then when we move over to H2, we're seeing lots of resources all coming down the line at one stage. So if we have a look at some of the main objectives of H2, the key thing with H2 is it was made with HTTP 1.1 in mind. So it should use the same methods and status codes, URLs, and basically it should allow browsers to make a decision and be able to support both. There's a high emphasis on the kind of backwards compatible model being introduced with HTTP 2. The other main features or objectives were to improve the end user perceived latency, address the head of line blocking introduced by HTTP 1, and enable parallelism into single connections. So as well as performance benefits, there are also security benefits of using H2. There is a misconception though, however, that H2 requires a TLS connection. That isn't 100% true. The protocol can support non-secure connections, and the requirement for TLS has actually come from the browsers enforcing a TLS connection in order to use it. In order to meet these main objectives set out for the protocol, there are 3 major features available to us today to use. The first is multiplexing, the second is header compression, and the third is use of the server push. Let's take a little bit more of a look at those in detail. The first feature we can look at is multiplexing. Back in the HTTP 1.1 world, you'd have a single request response pattern. This means that for every request there was a single response. That means that we often had the introduction of head-of-line blocking. So if one of those, in the example we've got here of a car travelling down a motorway, in order to transmit data, the car would have to travel to one end of the motorway and then travel all of the way back. If that car were to break down mid-route, then it wouldn't be able to start transmitting any other data until that car had been fixed. If we move over to the H2 world, we introduce binary framing. Binary framing is basically taking packets of information for each request and breaking them up into some header information and some data information. What this means is it gives us the ability to basically send packets in any order, get them down to the client, and then the client can then rebuild them independently of anything else that it's received in the meantime. So in this example here, first of all, we see we can allow streaming of content to start with, and we can interleave those streams. So if we look at the example of the motorway here, we can then send more cars carrying information potentially about different responses, different bits of data. And when they all arrive at their destination, they can all be organized into into the correct objects. This also gives us the ability to prioritize these streams as well. So when we're sending content, rather than sending everything at once, we can make sure we send the critical resources that maybe are going to be that rendering may be dependent on. In which case, the browser can receive all of those resources first, and then we can start sending images and things like that secondary. The second major feature of H2 is header compression. If we look back at what we had in HTTP 1.1, first of all, headers were sent in plain text. We were wasting bytes by not compressing them. Secondly, there was about 80 to 90% repetition in a typical web page. When you think about every request that you make, pretty much has similar headers attached to it. And finally, the other issue in HTTP 1.1 is that you'd have long cookies. So the more and more we've seen the introduction of cookies, these all add weight to every request that we send. And if we're sending the same one on every request, we go back to the issue about repetition. When we move over into the H2 world, then we introduce a technique called HPAC. HPAC is made up of two main features. The first one is that the client and the server share an index table. That index table is broken down into two major parts. Static content, which is typical HTTP headers that are used in most connections, and then the second part, which is new dynamic ones that get added as you build and go through the page. The client and server will share this information, and if any header is being repeated and sent again, instead of sending the raw information, we'll actually send just the index value from the table. That can then save and reduce in a large reduction of the header values. The second main part of HPAC is that we apply Huffman compression. What this means is that when we are sending the actual values rather than the index values, then we're not sending them in plain text. We're actually compressing them down to be as small as they can be. The third feature of H2 that we want to talk about is server push. So if you think about this in the HTTP 1.1 world, essentially a server would wait for a request. There would be this one-to-one relationship between a request and a response, and there would be a slight delay. As the browser discovers what it needs to call, then obviously that's going to take a little bit of time as well. And then finally, as a solution to this, we've used inlining as a way of sending information as soon as possible to the browser without having to make additional requests, but obviously we've caused cache issues with that. So every time we've introduced something in inlining, we make a change, maybe a small bit of CSS, then the whole HTML page or the larger object that it sits in has to be, then becomes invalid in terms of caching. If we think about this in the analogy in the picture, then if your car breaks down, then you have to wait for the recovery vehicle to turn up. If we move on to HTTP2, then we have the instant fix, the push. So what we can do now is make one request, and the server can send many files as a response to that. So if you think about when you request an HTML file, then you know that you're going to need the CSS almost instantly to then try and render that. And you have the ability here to send that with the HTML and not have to wait for the server to receive the secondary request from the browser. We also have, as we've seen before, around binary framing and streaming and multiplexing, then these new requests are basically a separate resource, and then they can form a new stream. As I mentioned before, the previous solution to this was using inlining, but that could have cache issues. Now, because we're sending something as a separate file, then that can be cached, and it can also be reused across other pages. And then finally, it's worth pointing out that if the browser already has the object in cache, then the request can also be declined. So having covered the main 3 features of H2, there are a few other considerations that we need to think about when using the new protocol. The first one is that H2 can free up resources. Currently, there is one connection per request per client when you are using an H1. However, when we move to an H2 world, then there will be one connection per client. So that can dramatically reduce the number of connections the server is having to maintain for loading one web page, for example. This frees up resource, certainly in the connection space and memory, so the server could potentially do more with less. As with all things performance, when you peel away one layer and improve one area, you then find you may start introducing a bottleneck somewhere else. And what we may start finding is that a lot of our TCP connections have been optimized for many small connections and small objects. Now, we're actually maintaining one connection that's essentially sending the whole web page down that one connection. For example, if you then start receiving packet loss, that's going to have a much bigger impact than if you were kind of spanning across 6 connections in a previously H1 connection. So where we see in the picture here, we've kind of built our motorways to manage congestion pretty well so far, but that can all change, and then when you start having to close lanes and things like that, it can cause massive tailbacks. And the same might be thought about for H2, and I think as we move forward, we may see that there'll be different recommendations to how to optimize TCP. So a quick wrap up from me before I hand over to Rick. We had HTTP 1.1 for a while. It was the horse and cart of the transport world. This was great because it gave us a long time to learn about it, understand it, and to optimize the delivery of what we were doing today. If we think about where we are today with H2, we're probably at the kind of initial stages of like the first car. We know that we can use server push versus inlining in terms of the optimizations we used to do. We can also address the sharding issue that a lot of people have raised suddenly goes away by maybe resolving the same request to the same certificate and IP to continue sharding, and I use that term lightly, in the same way that we have done in HTTP 1.1. And now we've also got the recommendation that you can now serve as many files as you like in comparison to HTTP 1.1, where the recommendation was to concatenate and serve as little as possible. This opens up better options for caching, making changes and getting churn through different resources, and it may even make the deployment process a little bit easier as well. And then tomorrow, so like I say, we're at the kind of early stages, so where do we want to get to with HTTP 2? I think first of all we could sort of end up seeing some pretty intuitive uses of push. There are no real guidelines around it at the moment, and we may start to see that moving forward. I think we're going to have to use careful use of prioritization. So we're relying on the moment at browsers to reorder and get the most important objects first. There may come a time when we deem something more important than a browser would by default, and we need to be careful and we need to think about that moving forward. And then finally, I think as we progress, we'll see better tooling and better understanding. At the moment, some of the tooling that we currently use with HTTP 1.1 is not going to work out the box, and we should see over the next year or so some better tools, and certainly debugging and performance related, being either adapted or developed. So that's everything from me. I want to pass over to Rick now, who's going to talk you through some of the experiences they had when they started implementing H2.
Hi there, my name is Richard Still. I'm a technical architect at the Financial Times, and today I'm going to talk to you a bit about our experiences with migrating our new site to H2. So we're not enabling H2 on our existing website. We have a new version of ft.com in the pipeline, dubbed Next, and that's where our H2 work really has focused. So I'll just take you through a few relevant architectural points. I'm not going to take you through everything, but some of these are relevant to H2. First of all, it's a greenfield development. It uses a microservices architecture written in Node. It's continuously deployed. We're running on Heroku, which really helps speed up development and also helps with the H2 transition, which I'll come to later. We're depending on a number of other services. Obviously, a front end of a modern website is pulling in assets and services from many different domains. Some of those are ours and some of those aren't. Thankfully, not yet bogged down by years of cruft. So we've got a clean slate and we can take a fairly hard stance with some of the heavier things that are currently hitting our site. The performance is really very important for the new version of FT.com. It's a responsive site, unlike the old one, and having it move very quickly on mobile devices, new and old, is a key feature for us. So the first challenge is, of course, getting access to H2. And when we first started this, we didn't really have a lot of choices. Our only practical choice was Akamai. You're limited by availability in the market. That obviously is changing very rapidly, but for us, we were limited with Akamai. And you're further limited by organizational constraints, or at least we were. So the FT is not a huge organization, but it is owned by a very large organization, and there are some business processes and things that perhaps will get in your way. So the plan of attack. You really need to understand the landscape where all of your connections are happening. So for us, we knew that moving to HTTPS was going to be the single biggest challenge. FT.com is predominantly on HTTP, bits of it are on HTTPS, and all of the supporting services that have grown up over the years that Next will still use are still on HTTP. So obviously over time as well, you need to try and consolidate your domains. Even though you can use domain sharding with H2, it does ultimately resolve to a single IP address and a single certificate, I believe. So practically, I think the limitation from an implementation perspective doesn't make much of a difference. And fundamentally, we need to measure impact. That's really very important, not just for H2, but for the site as a whole. So how did we roll H2 out across Next? First of all, we created a new H domain specifically for H2 usage. We knew there were going to be lots of small changes in lots of different places, not just limited to software, but also platform changes and potentially as well business process changes, specifically around ads. So for a long time we had HTTP pages with assets and services being loaded over H2. This is because quite a few of our services that weren't on HTTPS yet would simply have stopped working, and we basically didn't have a viable product while that was the case, so we couldn't make the switch. We started with Speedy. Everything you do or would do to enable Speedy on your site is equally valid for H2. So Speedy was what was available to us right at the start, so that's what we went with. We're using a single Akamai config. I'm not sure whether or not you can use a single IP and certificate across multiple configs. The Akamai guys will certainly help you with that. And this is something we did over a period of months. So there were so many changes in so many different areas. It wasn't worth trying to take a big bang approach, and that's kind of very much against the whole philosophy of the project anyway. So it's something we picked away at, and eventually, a few weeks ago, we finally flipped the site over to HTTPS. Not quite H2 yet for the full site, but we're almost there. So quick wins for us. These static assets for our new site, i.e. the built output from our microservices, are already stored on S3. an S3, if you enable website hosting, will give you an HTTPS backend by default. The supporting services that we use, so Polyfill service to ease development with older browsers, our image proxy for the delivery of responsive images, and our build service, which delivers standardized UI components and their related assets. So these are all things that we have direct control over, so it was pretty easy to enable HTTPS and H2 for those. And obviously we're on a single domain, so we now use the path to namespace. A quick note on Heroku. Obviously it helps our velocity in terms of delivery. It also made using H2 or enabling H2 very easy for all of our microservices. You get HTTPS by default. And I think the critical thing to remember is that your origin domain obviously doesn't have to be the same as your website domain. And it doesn't need to be H2 either or speedy. It just has to be TLS enabled. A quick word on API proxies. The FT use a number of third parties to enrich the product's experience for Next, markets data, and video being two of the bigger ones. We have microservices which front those APIs so that they can be directly consumed by the front end. And to enable those on H2, we have to pipe them through Akamai. It's not cacheable content, so really we're just using Akamai as a proxy here. That's something we really need to look at the performance impact of. Perhaps we can introduce a little bit of caching, because you are ultimately introducing an additional step and building up a little bit of latency potentially. So pain points. You have to have HTTPS origins with Akamai. It's a very reasonable thing to do to insist on an HTTPS origin if you've got an inbound HTTPS connection. But for us, we didn't have an HTTPS origin for our video platform, which is Brightcove. The exception is HLS, but because we didn't want to use a Flash player, HLS wasn't really an option for us, at least not on desktops. So at the moment, video is HTTPS. It's just not H2, and it's currently coming from somewhere else. The legacy stack for us was pretty painful. One of the big reasons for using Heroku is we knew how painful it was going to be. You guys may well have your own pain to deal with, but I'll leave that to you. It's something to be aware of. It certainly took a lot longer than I was anticipating. Advertising. We're not quite there yet with fully HTTPS enabled adverts. It wasn't actually as bad as I expected though. Most of the platforms, at least the ones that we're using, of which there are quite a few, seem to already have HTTPS, which isn't really that surprising if you think about it. Not so sure about the agencies. There's a few we know that seem to be struggling with HTTPS. I really don't think it should be a big surprise to advertising agencies that people need adverts delivered on secure websites, and I suspect that once we've been through it, it shouldn't be too hard. For us at least, it's also not just a technical exercise. We've got an ad sales and operations team, and actually we need to go through them. They're effectively a third party, albeit one in your own organization, so that does slow things down a bit and can make the conversation, because it's not direct, more difficult. And we did write some additional tech specs. We already have specs around our ads. We put some additional things about time for delivery and, of course, HTTPS. So that's something that we're hoping the adults team can successfully enforce. Okay, so on to measurement. Measurement is, of course, fundamentally important to understanding the performance impact of changes you make. So to start with, this was a little bit painful. We couldn't measure the impact over time because of the nature of the project and the development stack. Remember, it's a continuously deployed microservices architecture, so there are too many incremental changes to the site made all the time. There might be 100 releases a day on Next. We've got a low volume of users, relatively speaking, especially mobile users. We're at 5% of subscribed users. Those are premium users. So that excludes all anonymous users and all registered users. Mobile users, predominantly iPhone and iPad, are going to be using the web app, and there's currently no way to opt into Next directly from the web app. Android users are split between ft.com and the native app. So we've got some of those guys. Our RUM analytics are a little bit beta, so the instrumentation has to be taken with a slight pinch of salt. We're still ironing out the bugs there. On the plus side, the users that we do have are early adopters, so our H2 take-up is actually really good. The desktop users that we have are generally based in large organizations, so banks, large law firms, big corporations. So the connectivity they have is likely to be high bandwidth and low latency. It's good for their browsing experience. It might not actually be so good for establishing whether H2 has a good impact on your website or not. So how do we implement our analytics of H2? So first of all, we looked at a graph of H2-enabled browsers versus everything else, and we saw a nice drop in the load time for the page. So that's all the static assets, including images, fully loaded. And it was great. We were happy. It was obviously a little bit simplistic. You're basically talking about cutting-edge browsers versus everything else, including things like Blackberries. So what we did is we enabled a split test via the Akamai config, and we integrated that with our RUM real-time analytics. So we set some flags at the edge. We set one for whether the user's on a mobile network, the bandwidth, and I know that's a little bit flaky, whether the user's on an H2-capable browser, whether their current connections were H2-enabled, and the round-trip time. So what we wanted to do is compare users who are on a capable browser who didn't have an H2 enabled with those that did, and that gives us our split test. So this actually boiled down to Chrome's version 40 to 42. We didn't have the RUM data 43 because of a bug, annoyingly, in our analytics, which we're currently fixing. So unique users on Next with H2, it's basically half. This will fluctuate a little bit, but half is where we're at, which is pretty good. I think over time that's going to go down as more users migrate from ft.com and bring with them their legacy browsers, like IE8, which is obviously horrible. So we've run our split test, and with excitement building, we went to have a look at what the impact was. And there wasn't any, and which was, of course, very disappointing. So we kind of dug a little deeper. If we filtered by users on mobile devices, and whether or not a user is on a mobile network is determined by Akamai at the edge, and it was done, I believe, by doing an IP lookup. So here you can see that there is actually a big impact on the load time for those users. What is this actually telling us? Everything's a little bit beta for Next. We've got a relatively small amount of analytics data to report from. Any statisticians would probably be shouting at me right now if they knew what the numbers were. So we know then there's not enough data there yet. We might be skewed by the type of user. So I mentioned before, a lot of desktop users are on very good internet connections, and the bulk of our users at the moment are those desktop users. Our pages are pretty lightweight. It's not the Daily Mail. We don't have tens and tens and tens of images, or perhaps hundreds. We've got a fair few, but it might be that we're not quite making the most out of H2 yet. And as I mentioned, we just don't have enough data to really be authoritative about what the impact is. So what's next? Obviously, we need more data, and we're going to be running the split test for a good few weeks, possibly months, until we really understand what's happening. We need deeper analysis of how we're using H2 and also what the server-side implementation is. There are tools out there now which will tell you how close to the spec your chosen H2 vendor actually is. So understanding how the prioritization is working and how effective the H2 implementation is going to be part of the analysis. We want to use H2 more widely. Depending on which page you look at, we might have between 50 and 70% of the page coming from H2. But that's not everything. And we really need to do something about ads. We're not sure what yet, but there needs to be a lot of thinking there, because so much of the payload is going to come from advertising that ideally you want to get that coming through your H2 connection as well. It will really help things out. So a couple of extra perks, at least for us. Google are going to use HTTPS as a ranking signal in their scoring algorithms. So moving to HTTPS is well worth doing anyway. And there's a lot of noise, especially with all of the uproar about the NSA and GCHQ spying, about the use of HTTPS generally. So I think the trend for the industry is to move towards HTTPS. For us as well, it allows us to build a slicker user experience for ft.com. We don't have to drop out, like we do now, to a completely different stack to allow someone to log in or convert or subscribe in a different way. The UX can be far slicker and integrated into the single product. Like many organizations, the FT has some silos, and those different teams move at different rates and perhaps aren't joined up in their user experience. And of course, as Michael mentioned, you get header compression. Not quite as good as no headers at all, or rather no cookies at all if you're on a static domain for your assets, but it is still a performance enhancement. So a few closing thoughts. Optimizing for H2 could have a negative impact on the performance for older browsers. As Michael mentioned, a lot of best practice has grown up over the years about how to build a really fast web page. And H2 kind of comes along and undoes a lot of that. So you need to be careful. It's probably possible to optimize for both. It's something we've not thought about a huge amount. I don't think it'd be especially easy. There's some serious implications for your caching, so that's something to investigate. We might try that, but we probably won't bother. Next is really a forward-facing product. By the end of the year, we'll have perhaps 50% of ft.com traffic. I doubt it's worth the engineering effort to optimize for both old and new browsers. So that's our experiences so far. I hope some of that's helpful. If you've got any questions, do let me know.
That's excellent, Rick. Thanks a lot for sharing that, and some really interesting stuff there that I think a lot of people can share. Certainly based on the conversations that I've had with customers where they seem to think that, turning or moving to H2 is going to be an overnight thing, and I think you've shared, your experience there that it isn't something that will happen overnight, especially if you're moving from an HTTP to an HTTPS delivery method anyway. And I think, the ads and the things like that are going to be such common problems when people try and make this same transition. I think it's really valuable information. So thanks again, Rick, for sharing that with us. Hopefully everyone found it as useful as I did to kind of get those details. So moving on then, so we've got some questions come in. There's quite a few actually, so we'll do our best to answer as many as possible. What I'll do is I'll run through them and we'll take them whoever we think's best to answer them. So the first question we have is probably aimed at you, Rick. It's a question coming in saying that you've looked at the differences between mobile and non-mobile connections. Did you look into like raw bandwidth and latency and see if there are any differences and effects between those?
So yes, we did. We looked at both of those values. When we looked at the bandwidth, we saw that actually most people seemed to be on in the highest bucket, which means 5 megabit and above. And even the latency values that we're seeing were actually pretty low. So we did do some reporting around those doing things, and we couldn't really see an impact either way. I think the numbers simply aren't there at the moment, so it's something we'll be coming back to.
Cool. So hopefully, maybe we'll get some more data, and I know I'm certainly going to sort of stay involved with your implementation. Maybe we can kind of get those out, I guess, afterwards if we find some good information. Okay, thanks for that, Rick. Okay, second question then is someone's asked if I've heard the push feature can cause more problems than it's worth. Rick, are you right if I take this one?
Sure.
Excellent. Okay, so I think you're right, and there have been some discussions that you can end up sending something that the browser may already have and therefore cause an impact because you're downloading something, you're delaying something else, and the browser may already have it. However, it's really important to point out that before any push of content is sent, there is a preceding push promise. So the client has the choice in order to cancel these streams. So it can actually get that push promise, go and see if it has the object in cache, and if it does, then it can cancel that stream at any point, and therefore move on to other objects and things like that. So there is the capability to check for that. I think as well, there's also, it's worth pointing out what we covered in the talk, but what we're doing today is we are sending things that should be cached by inlining, but unfortunately they're not cached because they're sometimes coming down with kind of the HTML. So even if you were to kind of get push wrong and you were to send stuff and it was to all be sent and the browser did have it, you're probably not going to be any worse off than you are today. And I think the other thing as well is even on H2, there's a small window of low bandwidth use when the original HTML is being passed by the browser. So you'll send the HTML, that will get passed by the browser, and then if you're looking at bandwidth utilization, that's going to be very small for a very small period of time. So it gives us the ability to actually just fill that time. So hopefully your bandwidth utilization is almost going, as soon as you start sending stuff, you want to maximize it for as long as possible. So, I still think there is plenty of scope moving forward for people to experiment and for people to start providing best practice. And I think of all the new features, I think this is definitely the one where there's plenty of room for experimentation and innovation moving forward. Rick, did you have anything else to add on that, or you're not really that far down the line?
No, we've pushed this on our to-do list at the moment, so it's not something we've looked at yet.
Cool. Okay. Let's take another question then. So another one here. It says, I'm not an Akamai customer. What's the easiest way to move to H2? I mean, my answer is simple, is that's just to move and be an Akamai customer. But Rick, do you want to give a more unbiased view than myself?
Yeah, sure. So it's quite a tricky question, really. So obviously a huge amount will depend on the underlying technologies that you're using. If you've got a big legacy stack, you may be very constrained. Certainly, enabling H2 at the edge means you can kind of abstract away all of the underlying server technologies. So as I mentioned, we're using Akamai as a proxy, not just as a caching layer. So that will be enormously helpful. My experience would just be to go with whatever allows you to easily enable HTTPS. We've taken this microservices architecture, and that's been really helpful. And using a platform like Heroku was enormously helpful for kind of delivering that architecture. If you're not an HTTPS, then I guess whatever your organizational constraints are, you need to kind of get over those if you've got any. Yeah, I think that's about it from my end. There aren't many CDNs, I think, that offer H2 at the moment. Obviously, Akamai, I think, are pretty early in their delivery with that. I don't actually know who else is doing it.
Yeah, so again, the bias view is that we are the only ones at the moment, and some of the others are being a little bit coy on their adoption because a lot of their caching techniques uses Varnish, and Varnish have kind of come out and said, for better or worse, that until this is a proven protocol and there's a lot of take up, they're not even going to consider supporting it. So the other CDNs using that technology, as an example, have those challenges. So I think, as you kind of pointed out early on in your talk, is that if you are in that situation, then maybe investigate Speedy until maybe you've got a CDN or something that does support it, because I think you've proved that if there is a lot of work to do, then actually doing it early on Speedy can help while you wait for the support of H2 to come available. So okay, I think we're going to have to make this the final question just because of time. So it's an interesting one. It says, what does it cost? So I guess there's two levels of this question. I think I'll take this one, Rick. The first one is that in terms of Akamai, the simple answer there is that it doesn't cost anything. We're not charging for the use of HTTP2 because we see it as an underlying web protocol and not a new product. However, the caveat to that is that if you're currently not delivering your content over a secure delivery platform, then you will need to move to a secure, and there are cost implications to doing that. If you're then moving that question outside of Akamai completely, then I think the costs involved, again, I think as Rick pointed out earlier, it really depends on how you're delivering your website and your kind of complete stack. But high level, the main costs are going to be the setup and the maintenance. Most web servers now have support or plugins and things like that. So you're also not going to have additional hardware because they should be able to dual run. Again, if you're not an Akamai customer and you're still only on an HTTP server, then you've got that same problem of moving that traffic across. And if you're doing it yourself, then you're going to have to purchase kind of certificates, and there's going to be a cost associated to that as well. So I think, in summary, don't expect it to be a massive kind of major outlay in terms of money, but there is obviously going to be the installation, the transition, and then the testing. And I think, as Rick pointed out in his talk today, which is, even the testing itself is complex. It's not simple just to kind of measure and establish the benefit straight away. So there's always going to be kind of the time costs and elements to this. I think you have to be behind it. You have to have buy-in that you're going to, spend a lot of resource and time on this transition. But hopefully, fingers crossed, that we should see some benefits, and that certainly those early results that you've shown us, Rick, on the mobile networks, that could easily justify some of the investment in time that people are going to have to make on this. So hopefully that's answered your question. I'm just going to pause here for a little bit. So for those of you who sent questions in, We will do our best to get those answered, and we'll email those out shortly after this webinar. I just want to take the opportunity to thank everyone for joining us today and listening. Finally, if you do want to get a copy of the slides, remember to download them before you log off of the console. We are not going to be emailing out the slides. We will be emailing out a on-demand version of the webinar as well, though. So if you want to watch it again or send it to colleagues, then you'll have that ability. So just to finish up then, thank you very much, Rick, for sharing your experiences with us. Thanks again to everyone for joining, and I bid you all a good day.